Having seen the mechanism at the heart of SHM that drives it, let's see some terms we will often use in this connection. As always, we will try to get a more intuitive and visual understanding of these concepts than mere formal definitions that one can read from any textbook. So let's set this yellow ball in simple harmonic motion so that we can actually see these definitions at work. Okay, here you will notice that this ball is oscillating between two fixed limits. These are called extreme positions. If you think in terms of the spring mass system, then the spring is stretched to the maximum extent at this point or compressed to the maximum extent at this point, and therefore the force at extreme position is the maximum. And if the force is maximum, of course the acceleration will also be maximum. At the extreme position, the ball stops moving in one direction, starts moving in the opposite direction, so it comes to a momentary halt. So the velocity at extreme position is 0. Let us come to this central point here. This is called the mean position. This is the natural state of the spring. So it is neither compressed nor stretched. So the force is 0. So and acceleration will also be 0. But by the time the body comes here, it has accelerated for a while and it has attained its maximum velocity. So velocity is maximum at mean position. Let's see the next definition, that of amplitude. You will notice two oscillations here. Both these bodies are doing the same thing, the green and yellow, but the green is taking a shorter path while the yellow one is taking a longer path. So the yellow body is said to oscillate with higher amplitude. Amplitude is how far you go from this mean position to this extreme position. So how far or what is the maximum displacement a body undergoes. That's called the amplitude in simple harmonic motion. The third one is frequency. You can see two bodies doing the same thing. They are basically oscillating between again two same limits, but there is a difference. One is doing it rapidly, this yellow ball, but the green ball is doing it in a slow, sluggish manner. The difference is frequency. The yellow oscillation has greater frequency than the green one. Okay. Frequency is how often something takes place in a given time, say a unit time. Okay. So how frequently something happens, that's called frequency. So things which are oscillating rapidly have higher frequency. Finally, phase. Here we have two balls, the green and yellow. Both are doing the same thing, oscillation, with the same amplitude between the same kind of limits, with the same frequency even, that is with the same rapidity, but still there is a difference. And the difference is the green ball does something and the yellow ball kind of follows it, mimics it. And that is called as the lag, the phase lag. Okay. So phase represents the state of oscillation. So green body is always in an advanced state of oscillation than the yellow body. The yellow body follows after some time. For convenience, we break up this cycle, we divide this cycle of oscillation into 360 parts, say call them degrees, and then we can talk about these parts or phase lags in terms of angle. So if something is lagging behind by quarter of a cycle, we would say it is lagging behind by 90 degrees. That is how phase is quantified.